Alright, so today we're going to go over what do the actual graphs of sine theta and cosine theta look like. And they come from the unit circle, the basic sine function, the basic cosine function. They come from the unit circle. So here what I did is I just drew the unit circle. We know the unit circle has a radius of 1. So I took the liberty to write out those coordinates. If the radius is 1, then this is 1 comma 0. This is 0 comma 1, negative 1 comma 0, 0 comma negative 1. Another thing that I want us to remember is that our x value is our cosine theta and our y value is our sine theta. So these numbers actually give us a lot of information that we need in order to graph. So when we're graphing sine, we're going to only focus on the y values. And when we're graphing cosine, we're only going to focus on the x values. And so when we're graphing it, we also want to keep in mind that the actual x values here are your angle measurement in radians. So I took the liberty to convert the 0, 90, 180, 270, and 360 all into radians. And so we'll have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I label my x-axis as such. And we're just going to see what does one full rotation around the unit circle look like on your sine graph. Alright, so we're going to start with just the sine function. So since sine theta is our y value, we are going to start with just the sine function. So I'm just going to be focused on the 0, the 1, the 0, and the negative 1. Alright, so where do we have 0? So 0 degrees is right here. We know this is 0 degrees. So when our x is 0, our y value is also 0. So we're at 0 degrees and our sine theta value is 0. So if we're going to graph it, our first point will be 0 comma 0. Alright, so I'm going to do this for every single point. Now, let's move on to 90 degrees. So when theta is 90 degrees, which is here, our y value, which is our sine value, is going to be 1. 90 degrees is actually the same thing as pi over 2. So when I'm at pi over 2, my graph is going to be at 1. Now, when we're at 180, which is the same thing as pi, which is this, what is our y value, our sine value that we're graphing? That is going to be 0. So this will bring us to 0. When our degree measure is 3 pi over 2, or in other words, 270, our y value is negative 1. So that's going to be down here. And the last point for sine theta is when our angle measure is 2 pi, which is the same thing as our 360 degrees, we're actually going back to 0. So this is one full cycle around the unit circle. We started here, we went all the way around to all 4 points, and we ended back here. And this is the graph that it creates. So we want to draw our line. It actually curves. So this is what sine theta looks like. We're going to do the exact same thing for cosine theta, and since we're doing cosine theta, we want to make sure that we're focusing on our x values now in this plane. So I'm just going to go all the way around. When we have 0 radians, okay, we have our x value is equal to 1. So we actually start up here for cosine theta, all right? And then when we're on pi over 2, which is 90 degrees, our x value is going to be 0. So here our graph hits 0. For pi, which is 180, our x value is negative 1, so it drops down to negative 1. For 3 pi over 2, which is the same thing as our 270 degrees, our x value actually jumps back up to 0. And the last part where we're looking for cosine theta, our x value is a positive 1 for 360 degrees. So we jump back up here. And what does this look like? So some of us are usually inclined to just make it a V. It's not really a V. It curves very similar to how the sine curve is. So this is one cycle of sine theta and one cycle of cosine theta.